Longer.
Okay. No? I just was, it said that it's free and all that, go to the website.
So do you remember the night we were there together and I was going through his last ones that were current? And he went through Pandora and Hortonworks and so I was paying attention to see which one, because I've done any of these, right? Oh. And so I'm like, so which one do I? So I heard it voice and that was theirs. In my video, it's right here. So.
Oh, you went there? I saw that website.
So check this out. I mean, this is really cool. So Hortonworks, you have a sandbox. And yeah,
I've been to this website.
And then they have, these are like, they're tutorials. Like they take you through.
I took the tutorial too, but the thing was I was not able to download.
Oh, yeah, just go here to solution or to products, downloads. And then the Hadoop HTTP sandbox. And then they have VirtualBox, VMware, Hyper-V. I'd use VMware, that's why. So I downloaded that. Did you use VMware workstation? No. So they have a VMware player. So you can see right here. We're here to have a link to VMware player. So here's VMware and you can download VMware player. It's really first. So that in the machine you can run VMware. And you can do this, and it's like an image. You just look at it. It took about 4 or 5 minutes or something. I have a virtual machine.
Most time is there.
Oh yeah, by the way, Pat.
Hey, Nick. Sorry I'm late.
Figure out how the internet works.
Thanks. I can show like some things that if you guys want to stuff. Nothing too fancy.
No, they have web access. It's not your key. They need the key.
Yeah. Okay.
You have it? Okay.
You go to share. You share.
I can share some.
Yeah.
Share too many, you will crash my recording.
Right. That sounds good.
They're all the same, just don't use the deal auditorium.
Right.
Okay, leave the deal auditorium.
Okay. That's the one on Saturday.
You presenting?
I am.
I've got it back to AJ. But are you?
Dan, you want to start us off?
Yeah.
I need to grab a drink. Everybody broadcast online, we'll be starting in just a second.
What was that, Pat?
I'm going to drink, but I'll be right back.
Okay. So I'm going to assume that he hasn't turned off where he can run anything else back to that. Anyway, thank you all for coming out today. Also, want to thank our sponsors, such as Leonardo and the Utah events, the Big Day Utah Users Group, Utah Users Group, and a whole bunch of other people, right? So today, we really wanted to have a conversation talking about where people are at, some of the abstracts that we recently asked related to the air quality competition, things that teams have talked about wanting to focus on, and then also talk about some of the things that some people have already done, some of the things that will make the most sense to help the team and help you be successful on that. So I'm just going to take this back. Really all I want to say is, as a group, we need to find ways to make this successful. A lot of it is going to come from individual efforts. But also, the more people we get involved, the better. So please help spread the word. We'll try to help start getting more notice on meeting times, etc. But sometime soon here, we'll have a large meeting where we can have everybody come out, learn all the rules for the competition, here's some additional details from air quality experts, other things as well in August. So for now, I'll pass it on to Pat and let you go next.
All right, I'm just going to go over all of our basic things that kind of go over every time to ram into your head as much as possible. bigdata.org, that's the site where all the key things are. My display is a little messed up, but over here on the right-hand side, there's links to all of our major pieces. The JIRA tickets are all listed here inside the filter data set only. These are all data sets. There are some informational tickets in there as well. So if you want to see the informational ones, you can remove this little label and we'll find those as well. And then these are the Excel files behind the forms. And we do link to these. Let's see, is this my data set one? Yeah. So as you can see here, if it has a JIRA ticket, then I've created it, I put that link in there. So somebody has submitted this JIRA ticket and they want us to look at this data. I put that in JIRA, it's got a JIRA ticket. If it has not, I have not put it into JIRA. So you can see I have a few here that I have not done. Okay, so the next day, these will pop up as well. So you should keep checking JIRA for other data sets if you don't have one that you're already working on, or you want something to do, they'll show up, more will keep showing up. The next big things are the abstracts. Was it Kira or somebody else that just asked, or Brad, that just asked, how do we know what's the most critical data sets to work on compared to what are the abstracts or what's coming in? That's why we started to do this abstract submission form. We want you to give us ideas of what you plan to work on in the competition. So when you go to that form, you submit your idea and it shows up on this list. If anybody hasn't seen the form, it looks like this. Air quality competition abstract idea submission form. Now again, if you think that you're going to make a team and then you're going to come up with some really cool idea that no one else is going to do, you should still submit it here. Our goal is to get lots and lots of submissions here, and then everybody picks from those submissions. Okay? You should be sharing that knowledge, not just trying to say, I'm the only one that can do this idea, no one else can do this. It should be shared, it should be up here. So if you have ideas of things that you want to do, this is where it goes. And there's a link to this, there was a link in the newsletter, and there's a link, I believe, on the website now as well. If not, I can get that for you too.
Just because you create an abstract doesn't mean that you have to commit to that particular project.
That too, yes. Yeah, all you're doing is think of it as you're throwing a bunch of ideas out on the wheel. That's it. These are just ideas of things you want to do. They can be as far off as possible. They can be very detailed, but basically just give someone the idea of what you want to work on, or what you think we should work on. And we're going to get outside people to help with this as well. This is not going to be a start group. We're talking to the state already. They have the link. Other people will be submitting things here too as well. So that's the research sites. And then, so I am behind also on a few of the sets we actually have to put to Open Civic Data. There are a few sets done right there. And so those sets will actually go up into the Open Civic Data site. Make sure, if you have a set ready, you need to fill out this form. It's right down here on the website, right there. Submit a data set will get posted to the site. I can't have you posting directly to the Open Civic Data set yourself because we're going to end up duplicating data sets. We don't want that. We don't want that. So you have to submit the form and then we'll push it up to the site. Does that make sense to everybody? Okay. What else did I have? I think that's about it. Yes.
So we download a data set, look at it, and we say, oh, this needs to be, quote, clean.
Yeah, define accessible, clean and fine accessible, yeah.
Okay, so what exactly does that look like? I mean, I can look at it and I can say, oh yeah, this has got, gotta fix the headers on it and make this thing more clean and stuff like that. What exactly does an output look like?
So the outputs that we were shooting for, what most of us were looking at, is on that Civic data set is something that has date and location about what it is. And usually I would suggest a tabular form, meaning if you think about this, sooner or later you're going to take this data and you're going to shove it back into a table or a list, a key value pair, something, some sort of database that you can, manipulate it in the future. You can compare it to everything else. You can collate it to everything else. So think of it in, you would need a tabular form and then some sort of either comma separated, maybe JSON objects are fine, XML is a possibility. And the point here is whatever you put up there, you want it to be easy for yourself and all the other teams to then download it and utilize it in their system. So whatever format makes that easiest to you and easiest to them is best. We can't standardize necessarily on one specific format, but we can guarantee the things that I look for is date and location. We need some sort of date and we need something to know what location we're talking about. and then some sort of format that everyone can easily use. Usually CSV, tab limited, something like that.
So I'm most familiar with CSV. I'm not a programmer or anything like that. So I'm thinking one of the data sets I was looking at had these headings with codes on them, and I'm thinking I need a metadata file or something to be able to explain here's what the codes mean. Can I just be like a separate text file with it, or do I try?
So the question was, how do I show the metadata or what the file is actually about? And Kieran kind of went through this with me as well. One, you need to produce all of the sources that you got the data, so we know where that is. I'm going to put that in the JIRA ticket, and I'm going to put that on the comments. And then two, yes, there should be some sort of metadata, some sort of dictionary, something that tells people what this is. Now, if you do like an ESOS or something like that, it's already there. There's already a file that tells us exactly what it is. But if you don't have that, if you have to go to a website and get that about the file, then you have to produce that as well. So yes, you absolutely should, and that can be either in the comments of the ticket, to the submission form, or just directly I'll put it on the open set data set. So, and then at any times, we'll probably want to zip. Like, you don't have to have one file too. If you've got month by month or year by year and you want to separate those into CSVs, we can zip them and then put the zip on the actual open set. So we'll do as much compression as we can, because obviously we got to be concerned about space. Does that answer your question?
Yeah, it's maybe one last follow-up one. If you have, year-over-year data or month-over-month data, is it better to have it in a single file, or like if the source comes in separate ones and you just want to get all of, so people can use it? I think maybe stick it all in one file, get the headers all where it needs to be, and metadata to be done, or do I want to keep it separate, or what would be the best?
So the question is, do you want to keep lots of little files or kind of one big file to make it easier? Which way is the best way to do it? So go back to the same idea. If you were a team competing on this later on, what would you want that's most accessible and easy? Little files, one big file? I don't know, there's a balance there. But the same part has to say is that we've got a lot of data sets to go through, and I'd rather you do whatever's quickest to get the data up there as well. So I think you got to balance that a little bit, but in other words, I would find what is quickest. If I can get month by month and drop each CSV in a matter of 5 minutes versus writing code and bring them all back together, I would definitely do the dropping each one by one. Because we need data sets right now. We need them clean. We need them defined. On the other side, somebody can write a loop to pull it into their own data store later on. So that answers your question. Okay. All right. Anything else?
We are meeting with CIOs on Friday as the first big data sig for the local CIOs here. So if you're at CIO level, or if you want your CIO to attend that, please let them know. They can find information about that on the LinkedIn. I don't know if it's on the LinkedIn. I would reach out to Nick at youthstaffing.com.
Yeah, so we're meeting with them. There's still a lot of talk on hardware, things like that. We will have a meeting next week on Friday. Go back to our normal time. There'll be newsletters out this week, so everybody know that. All right, so next topic, right? Did you want to go over some of the team ideas that you have?
Yeah.
Will you sit kind of here or something so that the mic
Yes,
is go?
I'll stand if
Oh, you can come up here.
No, I'll just stand here.
Oh, yeah, that'll work.
So let me give you a quick introduction about myself. I don't know that I've met everybody here. My name is Ray. I work here at a local company in the executive team. The name of the company is Blockcell. And I moved to Salt Lake about 3.5 years ago. So I'm new to town. If I say a few things here and there, just understand that I'm new to town and it's not meant to. Anyway, so the reason I got involved with this effort is because I found it very attractive. We wanted to be involved in data somehow, and then also make a difference to the local community. I try to give that back wherever I work. I'm from Austin, Texas, been there for more than 22 years. Very soon I get a little bit about myself. And my wife is Karen here. She is also going to participate in this effort as well, to the extent that we can. I'm not a IT person professionally. I have an engineering background, so if you talk JSON or if you talk a few other things to be my eyes will glaze over. I won't sleep, my eyes will glaze over. Please understand that. But I have successfully set up many teams and helped those teams succeed. So what I'll do is I'll be lending that expertise to the group. And then also, I have done very exhaustive work with statistical analysis, multivariate analysis, correlations, DOEs, you name it, and I've almost done it. So I've got very deep background in data analysis from that standpoint. So that was the other reason why I got engaged. So today I'll share with you some ideas on what makes teams successful and why teams flounder. You can have some of the best people on your team, and the team may not be able to deliver. Have you had that experience before? Experts on the team, right? Where the team flounders, and the main goal while the team was together never gets accomplished. Or the project gets extended and gets extended. Or there is creeping elegance. Have you heard that term before? Creeping elegance. The projects keep changing, new projects keep coming, and projects never go back. How many of you have actually seen this or experienced this? Right? So, is it the fault of the team? Is it the fault of the individuals on the team? What can you say? Maybe, maybe not. So, what makes teams successful? How do teams work together very well? I'm going to share a few thoughts with you. Point number one, does the team have a clear target? Does everybody know what the deliverables are? And can they see the deliverables very clearly? If the end goal is not clearly defined, it's very difficult to get there. It is something. But what is there? And what is that end goal? In my view, that point going from point A to point B is what it is. And what is that point B? And how will I know that I'm there? Can I see it? Does everybody on the team understand that? Second, what are the resources available? What is the timeline? How soon do we need to get there? So we start from point B. Once we have a clear definition of what point B is going to look like and what good looks like there, we start working back and identify the major milestones that will take us from where we are today, point A, to that point B. That has got to be a team effort. It can't be dictated from somebody or some higher up. The milestones have got to be created by the team. That is very important, because if in the creation of milestones the team cannot figure out those milestones, that's going to be a big stumbling block later on. So once the milestones are identified, they need to be put on a sort of a timeline. And that timeline has got to match the available time that the project has been entitled to. Having done that, it's time to get down to work and identify what actions are needed to cross each milestone. As you cross each milestone, it's a good idea to have a little bit of a celebration as well. And as you start crossing the milestones, there has got to be a check and balance matching what your actual accomplishment is with what that milestone was supposed to be like. And if there is a deviation, you've got to make course corrections as we go all along. This might sound like common sense, but many teams don't do it. For one reason or the other, it doesn't get done. And the consequence is the team veers off, especially if the inspection is not done between milestone, deliverables, and the actuals. The team veers off, and over a period of time, the team is somewhere else, the goal was somewhere else. Does this make sense? Is this rocket science? Not really, right? But the question is, how do we make sure all of that happens? And that is the secret sauce to success for many of these technical projects. I've been through many of these, and I look forward to working with some of the teams, or many of the teams, as we go forward. I'm happy to entertain questions. I don't need to use up too much time with this kind of a dialogue at this point, but I will be involved with most of the teams, hopefully. Anything else you would like for me to share?
I guess first questions from anybody.
What are some resources that you'd recommend for those of us? I mean, I have a reporting background, and I don't have a lot of analytics.
Right.
And how to share numbers.
That's a great question. So when we look at the tasks that the team has to go through, the first thing to start doing.
Will you repeat the question too?
Oh, sorry. Please repeat the question. I'll repeat it again one more time.
Just what are some resources that you would recommend for somebody that's new to statistics or this kind of analytics?
Okay, so what are the resources that I would recommend if somebody is new to statistics and analytics? Well, that can be a lifetime of work, honestly speaking. Especially when you are dealing with this kind of data and you are trying to understand the causal relationships between cause and effect. There are a lot of resources that are available. I would recommend starting to understand correlation and regression, and then going on to hypothesis testing, and then going on to multivariate analysis or designed experiments. That would be the roadmap that I would follow. This is the roadmap I used to teach when I taught Six Sigma. And I've been teaching Six Sigma more than 15, 20 years now. But that's the roadmap. Does that help?
Yes, it does.
And then if you need more details on what books to read or whatnot, I'll be happy to share that with you. All those things that I've used in the past. And then there are software packages that are very, very useful to do this. But keep in mind that not everybody may have the luxury of spending more time on software, but Excel is so powerful. People don't have a good understanding of Excel. And believe me, I am an Excel junkie. So almost 90% of the work I do is done in Excel. But the finer points of Excel, barely 1 or 2% of the users really know. For example, Monte Carlo simulation you can do. You can do optimization within Excel. You can do optimization hunting within Excel. So there are a lot of things in Excel that can be done. I think I answered your question. Okay.
And two other quick points on that. One, a lot of the other technologies have started downloading into Excel now.
Perfect.
And then another one is that there's a website link called Coursera that gives you access to things like John Hopkins training for free, a whole bunch of other courses, Stanford and others, all free training unless you want a certificate, but all related to data science, statistical analysis, and so on. And so you can download that, and if you want the certificates, you pay, and then you can get a cert as well.
Very good.
Okay, very good. Any other questions or comments? Very well. Then I'll look forward to working with many of the teams here, I suppose.
Yeah.
Okay.
So we'll have Ray, as we continue to help build out the framework for teams. We'll start breaking down how teams need to be organized, rules around all of that, and that will be part of the larger meeting that I mentioned we started today.
Sure.
Okay. Thank you.
Sure.
Tyler, if you're ready and able to present a little bit.
Sure, we can do that.
Okay. Excellent.
So give us up, everybody, just a minute, you can probably grab another sandwich or something. Please don't keep it recorded. Somebody can ask us. And we'll have to reshare the Google Cast, so you'll have your box. And this.
I have a question. I read this one. So that's why I'm down. I may not have it. So you're saying that I need to go into. Oh, on the thing.
Full screen share, it shuts this window, and then it'll publish.
I don't know.
You try it before it crashes. So that's the majority of the set up these fires.
But we don't download that. Can I do it too?
Did you recognize that the slide was getting cut off last week?
I did, well, no, I didn't recognize it at the time.
Yeah.
I need to get that slide back. I've got about 4 or 5 that I need to get posted out there, and, I'll put them on.
All right, thanks.
Okay, so. So, let's see, we can try and
Then can I go home? I am still in Moscow.
that's great.
You know, whatever I'm, you know, I'm teaching them.
Okay, so you're sharing, but it's using content, this is not, that makes sense. Yeah, well, it'll mess up your display a little bit, but extending doesn't. So I don't see some.
Okay, so you're just taking the
Good. Now, all I need to do is make sure you repeat this.
You can just Google Spark download, and it should bring you, this should be a prominent page up here. And I download a pre-built package because you don't need to do for this. If you want to write any SQL in Spark, you want to do that. But it's way smaller, and it doesn't take 20 minutes to assemble it because it references a whole bunch of stuff. So anyways, I would just do like a direct file download of the, if you got a cluster you're going to point this at, you can match it up for Hadoop 1 or 2 or Cloudera 3, 4, or 5. So anyways, so you download Spark, you unzip it, and if I got it up somewhere. You can go into the bin folder. So when you unzip it, it looks like this. Nothing too cool. But in the bin folder is a, on Windows, they have all the command, but you just want to use Spark Shell command. And so that is that's what's running right here. So I've got this command prompt that I've already got up. So I can actually so that just killed Spark. So I want to run it again. So Spark is starting up right now. It sets up just on my local machine here a master and I think 4 slaves because I've got 4 cores or 8 cores. So anyways, once you've got this REPL, and the reason I like it is that it's completely interactive, so you can see exactly what's going on as you're developing if you want to. So you don't have to use REPL. Of course, you can compile code, and you need a Spark context. Here, it's available as SC. So what we're going to do is go out and get those files, and I've written some commands down here. Okay, so I've got this val of text, and it's all 800 of those files. And so if I want to count how many rows we're looking at, I just say text.count, and this is going to print out a whole bunch of stuff. I know there's a way to shut it off. It's the logger. But if I just say text.count, it threw out an error first because it couldn't find to do, and then just kind of runs through, and it tells me we're working with 6.2 million rows. So more than a single Excel file can handle. It just read through them. This is 200 megabytes of data. It says it took it 3.5 seconds to do it. And it's because I'm running off of a single SSD. So now what we're going to do is we're actually going to get into how we're going to parse this stuff. So I'm going to make another variable in here, and I'm going to call it files. And you'll notice that when Spark does something like I make a value of files, Spark is lazy. It doesn't evaluate anything until it has to. And so when I said count on that last thing, it had to evaluate it, so then it went out and read it all. On this one, it says files. It just knows what I'm dealing with. And you'll see right down here, working with an RDD, and it's a pair of strings. The first one is the name of the file, and the second one is the entire contents of the file. So, so remember, we've got files that look like this, and so we want to get this data down to in here, and then write it all out. So, got another couple maps we're going to do, and so RDDs, or you just think of them as like huge distributed lists. What I'm doing here is I'm taking the files and I'm mapping it, and so this is working on each of the strings that represent the entire contents of the file. And well, that's the underscore too. I'm just splitting it. So I'm going to get an array, and it's going to be split by new lines, which is kind of what you would expect. And again, it didn't actually do anything. It just says, okay, I've got that. So then we probably want to go in and split it again. You'll notice that it's all split up. Everything in here is comma separated. And so we're going to go and split everything again and get an. And so now you can see you got an arrays of strings. Okay, and so we've got all these individual values in there. And so from here, you can do things. Pull this off to the side just a little bit. But when we're all done, we can define in here what it is we want to do. And so I can say, I want a case class. This is all Scala specific stuff. But you can say you want the station as a string, and we're going to skip the country because we know what that is. We want the state as a string. And we'll go with latitude as a float, longitude as a float, and just to be brief, we're just going to copy all the rest, the rest of the data. So I'll just call it data as a string. Wonderful. Should probably name it, huh? So, so we're going to call it air data. And if you guys ever use Scala, what it wants, all of the types in Scala are uppercase. Okay, so it's defined this class for me. In Scala, case classes give you a whole bunch of functionality that you don't even have to write out. And so now that I've got this class, I'm going to go and fit that data into this class. And the way we're going to do that is we're going to take the we're going to take arrays 2. And then we map it. So then what we're going to do is we're going to say we want a new air data. Actually, we need to map it. We need an intermediate step in this. And so we're going to map it. We're going to take those first values and put it on every line, and then we can go back and map it and get our data out. So you just say 0, and then we want the second part there. So that was the station name. If we go back and look at this, that's index 0. Because remember, right now I'm just working with arrays. And then we're going to want 2 and 5 and 6. And then we want X. We actually want the data. For some reason, this doesn't deal with backspaces very well. Like, huh? Yeah, it doesn't believe in mistakes. So I'm going to copy this out before it destroys it. Yeah, just let this throw an error at me. Okay, so we take that and we trim it, and then what we really want is a filter just on the entire array where again, it doesn't want me to do that, does it? It's the problem with working on a small screen. Anyways, I filter out all the lines that don't start with four numbers. And so when we're all done, we'd end up with a class, and it would have these first 4 values we really cared about, and then all of this data out here, and then we could transform, clean it up even more, remove the commas, make it tab separated. Clean up, throw the M's out. They probably mean there's nothing, so just go tab tab. That means there's nothing there. And then that would probably be about the way we wanted the data. So anyways, there's a quick introduction to Spark, which obviously isn't working as well as I'd like it to, but you can do it on your local machine. There's not a lot of install required. In fact, you can be up and going in like 3 or 4 minutes. So.
What was the original install? You mentioned the bin folder. Is it go to the site and download it and extract it, or is it?
Yeah, that's exactly what I did here. See this bin folder? It's in my downloads, Spark 101 bin Hadoop 2, which is the name of the download. So if I go here to downloads, I've got up here at the top, that's my my TGZ that I downloaded, and then the tar retains its date they did it on. And so, just extract the tar and
obviously it runs on Windows just fine. In other words, it doesn't need to be on a system.
Yeah, it's all Java based. So, you have to have Java home set, which is standard. And it's all written in Scala. You can write Java if you want. You can write Scala. There's also a Python plugin for Spark as well if you're more comfortable with that.
Now, so you're doing this kind of standalone on your laptop, but if you have Spark on the server, is that more inside a cluster, or is that?
So you can connect a REPL like this to a cluster. So I've got a cluster at work. It's a little 5-node, and I can, since it's all set up, all the environment variables are set right. There's a little bit of configuration to do with that, of course, but you just say Spark shell, and it instead of starting its own master, which it did in this case because it couldn't find one, there wasn't anything specified. It connects out to the master it's already running, and then I can run this on an entire cluster. You can run petabytes of data like this, and then like if you want something to be repeatable, like a job you run all the time, you can wrap it up in jar files and you just submit it to the server, to the master. So.
I really like that because we've been mentioning to people too is that as you write these scripts or anything, think about being able to put them on a large cluster. So you can do that because as we give you the large cluster, then that can be ready and available.
Yep.
So if we get lots and lots of files and you write a script for it, or even if you are working on just one on your laptop, if we can stuff all those files.
Yep. So, anyways, when you're all done, there'd be one more command that I'd run. It'd be sc.saveas. Wow. No, thank you. Save as a text file, and you give it actually no, not sc, just whatever I ended up with, like data.save as text file, and give it the file name, and then it just calls toString on every row and writes it out. Yeah, and so you can, it would take those 806 files and turn them into one file if I wanted to. So, are there any other questions?
You might have mentioned this early on, but on Scala, can you work on any language that's on the JVM, or do you need to use Scala?
No, you can use any language on the JVM. So it's written in Scala. So the full feature of Spark is in Scala. There's a few things missing in Java, and I think a few more things missing on Python. When you're using Python, you're really using Python. And I think some people have written stuff for like Ruby, so like JRuby and that. But in Scala, like if you get sick of writing Scala, you don't know how to write it, you can just write Java like in the Scala file, so it works.
Like you said, you can move it into a jar file too as well.
Well, yeah, and Scala compiles into jars because it's really just Java underneath. So.
All right. Hey, thank you, sir.
Well, I don't.
Okay.
It's 105.
Can we log into your thing and then let you go, or do you need to you probably need to take some stuff?
Yeah. How quick, Ben?
I don't know how much you guys want to see. Whatever works for you.
We could have him present just here in the group, and then you have anything the slide or anything that we can.
I was basically.
I
just put together something really quickly, and what I was putting together was how to kind of go to a website and automate collecting a lot of data that doesn't necessarily have super clean, that doesn't have the biggest interface. on the web. So I think compared to Tyler's presentation, mine's a little bit more about grabbing stuff from a website than it is about parsing the. So it's totally up to you.
Well, so it'd be nice to have that now, because you're going to be presenting hopefully here in the next week or two, right?
Yeah.
And we're at a point where we need to finish extracting as much data as we can, and then just start getting this data clean. Really, right now, if there's extra data that you need to be able to get to it quickly.
Right.
And then have it out there so we can all get it clean.
I can do it pretty quickly, probably.
I mean, Mike.
Go to the mic.
Yeah, it's got to find out.
So he'll touch on mine, and then we can let Pat go, and then that'll be helpful for the group here as well.
I'm over here and logging in, and I'll log into Google's Meet, and that'll switch it over.
Let's see, is there no? Yeah.
So,
Hold on a sec.
does this have a USB at all?
Yeah. Yes, please. There. Both sides.
Log in. I'll log in, so, account. Yeah. Darn it. Gotta remember this password, but. Okay. Hey, they finally changed our name. Scroll backwards. Come on. No. Where is my stuff? Oh, that's the wrong one. Okay, there we go. There is week 7. Start. That'll come up. Yeah, we know. Come on. Join.
Okay, can I cast my screen onto this?
Yeah, you're gonna hit the little green here. Share. Share your desktop. No, that's what always happens. That's what I was worried about.
Is it sharing now?
Well, you gotta go back to the mic settings. Hit that green again so it doesn't do this. There. Okay, now go to here. Go to settings.
Settings.
Yeah, and change this to the USB microphone right there. And then save. And now you can reshare. And I'll make sure you're set as the audio.
Okay, is that working? Okay, we good?
Looks like it. Did that? There's a little, yeah. I see it on here.
Yeah, we're good. Okay,
And then when we're done, hit the big red stop broadcast.
cool. Okay, so I'll be pretty quick because we're running out of time, but I'm just gonna suggest one way that you can kind of automate collecting a bunch of data from a website that might not be set up to easily get all the files in one fell swoop. So we're just going to look at this EPA.gov air data from JIRA right here. And if we click on this link, you can see that this is a landing page which has a bunch of different tools. And then you can click on download data. And right here, they do have an interface to like get a raw query, but you have to have a user account, which I don't have enough time to do. So I'm going to pretend that they don't have this interface because a lot of the sites that we're dealing with don't. And look at what they have in terms of data files that are already prepackaged. And that, as you can see, this is a page with a bunch of zip files that are separated out by year, and they've got some annual summary data. Scrolling down, they've got daily summary data and all this sort of thing. And there's clearly a lot of data here, but it's pretty hard to get at. I mean, we could go and click on each of these downloads one by one and download them, but that's pretty tedious, and no one likes to do that when we're using computers and we're developers. So what I'm going to do is just an example of how we might approach this problem to download all these zip files without doing the manual way. So we'll look at this hourly data, and all we have to do is figure out where on this page it lives. So to do that, I'm going to inspect the element and figure out how we can easily navigate to this using a scraper program. And I can see that this hourly data heading has an ID called raw, R-A-W. So I know that we'll be able to grab that, and then all the data is contained in this table down here, which has one heading row and then a bunch of rows with data files. And then I look through there and I see that there's a bunch of links that contain that links to the actual data. So really all I have to do is write a little script that that will navigate this document object model, trigger a download of these things, and then unzip them for me. And then I can have a bunch of CSV files that we can use some munging like Tyler was showing with Spark, or some Python code, or whatever the tool of choice is to clean that up into a more finalized form. And that's outside the scope of what I have time for right now. But just for this simple thing, here's a little script I wrote to accomplish that task. I really like Python for a scripting language. It's fast, it's powerful, and has pretty easy syntax. The platform, or the parsing library of choice for Python, in my opinion, is a library called Beautiful Soup. It's got a lot of documentation online. It's very easy to use. So what you can see in this script, I import that, and then all I have to do is give it the base URL, and then I use a built-in Python library to open that page, and then use Beautiful Soup to build up a parser for that page. And then after that, I am using this select command to go to the raw ID tag that I saw when I was inspecting the HTML of that page, and then I grab the next table that exists in the hierarchy. And I know that that table right there is the table that I want to download data from. And then I just loop through the row in the table and for items in row. And I basically am looking for A tags, which are links. And remember, when I was looking at the hierarchy in the actual HTML, I know that the links to the data files are all contained in these anchor tags. So where did that go? There we go. So I go in there and I finally get a URL here by grabbing the .zip file from the tag in the HTML and then combining it with the base URL. And then you can download things right in Python. What I'm using is curl, which is a built-in Unix utility to download it. It's kind of nice because it's got progress bar output, but Python can do this too. And basically what this does is it goes through that table, and every single link in that table, it starts a download. And you know, if I run this, sorry. If I run this, it will go out, grab that page, start processing it, look for the first data file, and start a download. And you can see it's downloading this, and it's not a particularly fast connection. I'm guessing that the site throttles this a little bit, but I can leave this running, and it'll probably take 3 or 4 minutes per download file, but eventually it'll get every file in that table. And then the next step would be to use either Unix utilities or Python utilities to unzip each file, look at the CSVs within, and figure out if those CSVs are clean enough for our purposes, if we want to use Spark to munge those CSV files, if we want to combine them, whatever we want to do. But this right here gives us a way to automate collecting the actual primary data from the web. Sound good, everyone?
So how did you get to the HTML file? Did you right-click and see the...
Yeah, so what I did, I mean, you can just view source, but if you're in Chrome, there's a pretty good browser. So, you know, this is just the website right here. If I right-click, and then in Chrome, I can go to Inspect Element, and that opens up this inspector. And so this is showing me the actual HTML of the page. And it's a nice hierarchical view that I can open up elements and stuff. So I know that, and also based on where I right-click the page, that will be where the HTML is highlighted. So you don't have to go through the HTML. You just right-click the element on the page that you want, and then inspect element, and it will come up highlighted in here. So I know in this case that this table right here is what contains the actual data that I want. You know, I can go through here and see that these are the links that I'm interested in collecting. But the problem is this table doesn't have a unique identifier in the HTML. It just has a class, which is purely for visual thing. So what I noticed is that this element right above it does have a unique identifier. See how it says ID equals raw? So when I wrote my little script, I basically used that to anchor me within the HTML. I searched for that first and then found the next table that follows that anchor in HTML. And once you have the table, you can drill down to the actual files that you're looking for.
So you don't need any software to see this HTML file?
This is pure Chrome, Google Chrome web browser, yeah. To the software that little script that I wrote, that was using a Python package called Beautiful Soup, rather. Yeah. But yeah, this is just pure web browser right here. Any other questions? Cool. Thanks, guys.
Thank you.